Thank you for joining us for today's webinar brought to you by CodeFresh Live. Today we are presenting Easy CI/CD for Fargate. My name is Taryn Jones and I'll be your moderator today. And our presenter is Guy Sultan, Solution Architect for CodeFresh. And he's going to show you how to create a container native CI/CD pipeline that deploys your application to Fargate using a built-in step that we created. We will be taking your questions throughout the session. Just please remember to submit them using the Q&A button on your Zoom toolbar rather than in the chat so we can keep better track of them, and we'll address them at the end of the presentation. This session is being recorded and a link to the recording will be sent to you by tomorrow. Lastly, please remember to reference codefresh.io/events for upcoming webinars, as we have fresh and informative webinars for you several times a month. So that's it for the housekeeping items. And with that, I will hand it over to Guy to start the presentation.
Thank you very much, Taryn, and thanks everybody for joining. So today we're going to talk about CI/CD for Fargate. Just before we start, a bit about myself. So my name is Guy Sultan. I'm a solutions architect here in CodeFresh. I've been with CodeFresh for a bit more than a year now. And as part of my role, I'm helping with onboarding customers, technical workshops, demos, talks, webinars, stuff like that. You have my email there, so feel free to ping me if you have any questions and need any help or anything like that. So what are we going to discuss today? So first, we'll give some introduction to Fargate and see what is Fargate. I know that there is some misconceptions about Fargate. Is it an actual service in AWS or it's an engine? We'll see exactly what it means. We'll talk about the two launch types for ECS, for Amazon's Elastic Container Service, which is EC2, which is the more traditional approach versus Fargate. We'll then talk about the architecture and deployment flow for Fargate on ECS, and then we'll see a live demo where I'm going to show you how to build a CI/CD pipeline for a Go application in this demo and how to deploy it to Fargate. And we'll finish with a summary and Q&A. We also have a link here for some documentation about what I'm going to show you, and we're also going to share the slides and the GitHub repo after this webinar. So first things first, what is Fargate? So Fargate is a serverless compute engine for containers that works now both with Amazon ECS, right, which is the Elastic Container Service, and now also with Amazon EKS, which is the Elastic Kubernetes Service. In this webinar, we're going to focus more on ECS, as it's still very, very new, the support of Fargate for EKS. So it means that with Fargate, you can run containers without worrying about the underlying infrastructure. So this means that Amazon is managing the clusters, it's managing the EC2 instances. You don't have to worry about which instance types to use, the scheduling of clusters, optimizing the settings. So you can focus on creating the containers to run your application to create the business value. The second thing is that Fargate provides automated scaling. So it makes scaling very simple. Once the application requirements are set, the service will manage the required scaling for the infrastructure. And Fargate also allows you to launch as many containers as you want within moments, and scale them to run the most important applications. And the last thing, which is always a thing about Fargate, is the billing. So there are advantages of this and also disadvantages, but with Fargate, the billing is based on the CPU and memory consumption for your tasks. So you only pay for what your tasks uses. You don't pay anymore for EC2 capacity that goes unused. So that's part of the serverless compute engine part of Fargate. So as I mentioned, today we're going to focus more on ECS, so Fargate on ECS, and we will jump to AWS itself and see exactly how this works as well. So there are two options today for ECS, two launch types. First one is EC2, the second one is Fargate. So as you maybe understand by now, EC2 means that you have to manage and create your EC2 instances where your containers will run. Where with Fargate, you don't have to worry about the EC2 instances. You just define and point to the containers that you would like to run, and let Amazon know the amount of resources that your task will need. So let's talk about different use cases and see what option would be a better fit for each of these use cases. So first, let's imagine we have a large workload and we want to optimize it for price. What would be a better option, EC2 launch type or Fargate launch type? So if your workload has a consistent demand for many CPU cores and many gigabytes of memory, and you want to optimize it for price, then you should consider EC2. Because, and of course, you will be responsible for managing the cluster and optimizing it, but you will be able to take advantage of EC2 instance saving strategies like spot instances and reserved instances. And with this, this can be a cheaper option. So if you want to optimize it for price, EC2 might be a better option. If you have the large workload, but you want to optimize it for low overhead, then as we understand by now, managing a large cluster of EC2 instances can be somewhat hard. You need to make sure that they're all patched, they're secure, and updated to the latest version of Docker and ECS agent. So if you don't want to deal with any of these overhead, then AWS Fargate can be a great choice. Just as an example, if you remember the Spectre meltdown vulnerability, when it was announced, customers that were using EC2 had to make sure that they patch and upgrade their instances, while customers that were using Fargate were protected automatically behind the scenes by AWS engineers who patched the underlying infrastructure. So if you want to optimize it for low overhead, then Fargate is probably a better choice. What about small workloads with occasional bursts? I know that a lot of you, this might be the use case for them. So let's say you have some workload which is small, but it has occasional bursts, such as like a website that has traffic during the day, but low traffic at night. So for this, AWS Fargate is a fantastic choice, as you can scale down to one tiny container at night, costing very little, but still scale up during the day while only paying for the CPU cores and gigabytes of memory that your task requires. So for this use case, Fargate can also be a great option. And finally, for batch workloads, so if your workload consists of periodic tasks, such as a cron job that runs once an hour, or occasionally occasional jobs that come from a queue, then Fargate is also a great fit. So instead of paying for an EC2 instance and having to start and stop it between uses, you can just ask AWS Fargate to run your container when you need to and stop paying when your container stops. So these were a few popular use cases, and you see that Fargate can be a great option for a lot of these use cases. A bit on the architecture, on different components of Fargate on ECS. So we have a few different components here, and before we go and see it in Amazon and see the actual demo, it's important to understand the differences. So as we understand by now, Fargate, right, is for running your containers in the cloud in Amazon. And we have a few things here. So first, the task definition is a collection of one or more container configurations. Okay, so some tasks may need only one small container, while other tasks might need 2 or more potential linked containers running concurrently. So for example, let's say you have an application that has some backend component for it, but it also needs a database, right? So you need multiple containers, so you can still manage these multiple container configuration under the same task definition. Okay, it allows you to specify which Docker image to use, which ports to expose, how much CPU and memory to allocate, how to collect logs, and define environment variables. So these are the task definition who are managing the container definitions. As for the service is used to guarantee that you always have some number of tasks running at all times. So if a task container exits due to an error, or the underlying EC2 instance fails and it replaced, the ECS service will replace the failed task. So this is the service. The service, it's also important to note that it can be configured to use a load balancer. That's what I'm going to show today in the demo, so that as it creates the task, that it launches the containers defining the task definition, then the service can automatically register the container with a load balancer. So it's important to remember that tasks cannot be configured to use a load balancer, only the service can. And at the end, there is the cluster, and that's the actual cluster that you can refer to, and you can have, of course, multiple services under the same cluster. Let's talk about the deployment flow. Then we will jump into Amazon to see exactly how you can create an ECS Fargate cluster and service, how to link it to a Docker image, and then we will see what we're going to do in the actual demo for CI/CD. So we have our cluster, right? And we have a service, which would be a load balancer type of a service. And it will then service our users to be able to use our application. Inside the service, as we mentioned, there is a task. So if you look at this diagram here, it also shows you the actual EC2 instances that are running in your cluster. If you're using Fargate, then you don't have to worry about these EC2 instances. If you're using ECS with EC2 launch type, then you do have to worry about the EC2 instances. But regarding the deployment flow itself, it's kind of the same. So what we have is before the deployment starts, we have some task under some service, running some application, some container, right? Then we're going to create a new revision from the current task definition of the service. And we can specify any image and tag that we want to use for this new task revision. And then we're going to update the service with the new task definition. So there will be some time where we'll have the old task and the new task, and eventually the old task will be removed, and we will be left with the new task.
Hi, Guy. I have a couple of clarification questions. I hope it's okay if I interject. Roman's just asked why 3 clusters? And then we have a question on does it leverage Kubernetes for cluster management and orchestration? And if you're getting to that, just let us know.
Sure. So I know it might be a bit confusing. That's my fault. It's not 3 clusters. It's all the same cluster. I'm just showing 3 phases of the deployment. So this is phase 1. Same cluster, then phase 2, and then phase 3, right? So it's all the same cluster. This is the first phase where we have our current task with our current service, and then we're going to run a new task, right? So now our cluster would have 2 tasks running. One of them would be the primary one, and then we will remove the old task, and we'll be left only with the new task. So only 1 cluster. So yeah, sorry for that. That might have been.
And then Jag wondered as well, is the Fargate cluster is Kubernetes or is it Swarm?
So it's not Kubernetes. As I mentioned at the beginning, Fargate today supports both ECS, which is the Elastic Container Service of Amazon, which is not based on Kubernetes, but it also now supports EKS, which is the Amazon Kubernetes service. But this is very new. So what we're talking about today and we're focusing about today is Fargate as a launch type for ECS. So let me just open the Amazon console and show you what I mean, and then we will go to the demo. So if you go to your AWS console and you search for Fargate, you'll see that there is no service called Fargate, right? So this is one of the misconceptions about Fargate. It's not a service, right? It's an engine, serverless compute engine that supports ECS, and now also EKS. So I can go and simply click on ECS, which is again the Elastic Container Service for Amazon, which is not based on Kubernetes. And I see that here, I can go and create a cluster. And this cluster can either be, right, for example, EC2 Linux plus networking or EC2 Windows. These two are ECS clusters that are using the EC2 launch types, right? So I would have to manage and maintain these EC2 instances, in this option running Linux OS, in this option running Windows OS. With this option, I can select a cluster which is powered by AWS Fargate, right? So these are the two launch types that I talked about. So with ECS, you can either choose the EC2 launch type and then manage your actual EC2 instances. You can then choose what instance types you would like to use, etc. While with Fargate, you don't worry about these things. You only focus on the containers of your application, and AWS does the rest. It takes care of the infrastructure for you. So I created some cluster here. I called it Fargate demo, and I see that I have one service running for my cluster. If you see the launch type for this service, it's the Fargate launch type, right? Because I used Fargate, and all I had to do, and I can click on this service, is I see that I have one task running under this service, and this task is pointing to some Docker image, right? So I have some Docker image here that I pushed to ECR, right? I gave it a name. And this is the image that I'm going to use for my task. So I can actually go to ECR here for a second. And I can find this image, right? So I have this repository and I have a few images here, and I can then choose any image from my ECR repo to be used in my ECS task inside the cluster. So I have my ECS cluster. It's going to use Fargate launch type. If I go to the service, I can see the target group used for this service. And as I mentioned, we're going to use a load balancer, right? So I can see the load balancer name here, and I can go to my load balancers and search for it. I can find it here. And then I can just take the DNS name, copy it here, and I use the port 8080 to expose my service. And I see that this is my application, right? So it's a simple Go application running in a Docker container, and this is what it does. It's just a simple web server, and I see that it's running and it's showing me the output. Okay, so this is my cluster and my service and my task. Now let's make some change to my application, push it, and see how I created a CI/CD pipeline to automatically then deploy and make deployments and changes to my cluster. So going back to my presentation, in this demo, again, I'm going to show a CI/CD of this Go application to Fargate. I pasted the GitHub repo for this application here, and you can just go and fork it. It's a public repo, right? So you can go and use it. Here it explains exactly how to use this and how to build the image for this application. So it's a containerized application. And for this demo, I'm going to use CodeFresh as a CI/CD platform. So for those of you who don't know, CodeFresh is a container native CI/CD platform for microservices. With CodeFresh, every step in the pipeline runs as a Docker image. It's a SaaS platform, and it's pretty intuitive and easy to use. So we'll see, how can I build the pipeline in CodeFresh for ECS. So going to CodeFresh, this is my CodeFresh account. I can then look and I see that I have an ECS project, and I have my my pipeline here, and we will run and make some change to the application, see what happens, and we'll dive into the pipeline itself and see exactly what I did here. So let's open my terminal, and I hope you can see it well. Yep, and this is my local clone of my repo. I can go to the source folder of my application, and let's make some change to the application. So it will print something else, right? So let's now say I'm a Go application running in Docker container, deployed to Fargate, right? So I can then save my changes, commit them, call this deploy to Fargate, right? And then I'm going to push my changes. So pushing my changes now should automatically trigger a pipeline here in CodeFresh. And this pipeline will now take my repo, and I see that it just started. It will clone the repo with the changes, build the Docker image for my updated source code, run some unit tests, and push the image to my ECR registry, and then finally deploy it to Fargate, right? So if I go to back to my cluster now, and I look at the tasks, you see that currently I only have one task running, right? And this is my previous task. And I saw that the load balancer DNS endpoint shows me still the previous output, right? Now I see that my repo was cloned. It's now building my Docker image, finished building my image, running a test. Then it will continue pushing my image to ECR and finally performing the actual deployment. So this step was also completed. Now it's going to start the deployment flow itself, and I'll show you, of course, how to perform this deployment. Let's go now back to my ECS cluster, and I see that a new task is now provisioning, right? So it pushed my updated image to ECR. It's now creating a new revision of my task definition with this new image. Okay, it's still provisioning it. So now if I will look at the DNS endpoint of my load balancer, I still get the old output, right? But now I see that the new revision is in running state. And if I go back to the deployment flow, right? So this is what we said. We start with one task, then a new task definition revision will start. And I have two of them running side by side. And then we will point the load balancer service to the new task and eventually remove the old task. So I go back to CodeFresh. I see that it's actually completed. So that it's completed with success. And now if I go to my my load balancer and I refresh it, I see that I got the new output, right? So now I see I'm a Go application running inside Docker container deployed to Fargate. So let's see exactly what did I do here. And if I go back to ECS, I might now still have these two revisions. Eventually, it will remove the old one. Great. So let's look at my actual pipeline and what I did here. So I can click on my pipeline and see how a pipeline is built in CodeFresh. So with CodeFresh, the pipeline is built using declarative YAML, and you can either build this YAML inline, which is what I did here, or you can also use YAML from repository. So you can store this CodeFresh YAML in your GitHub or Bitbucket or Stash, Azure DevOps, whatever Git provider you use. And you can store your YAML file there in your repo and manage it under version control. And then to build the actual pipeline, it's pretty straightforward with CodeFresh, as you have all of these built-in steps, and you can just click on each of these steps and add them to your pipeline. So for example, for cloning Git repo, I can just click on the Git clone step and copy it to my pipeline. By the way, you see that for cloning a Git repo, instead of pointing to a hard-coded value for my repo, I can use these system variables. We then, once we create a Git trigger, right? So I have a trigger here, and we'll see exactly what I did here. It's going to run my pipeline for every commit, which is what I did before, right? I committed some changes to my master branch. It then triggered the pipeline, and then we parse the JSON payload that comes from GitHub, and we dynamically populate these variables with the data from the webhook. So I have my repo. Then it's going to build my Docker image, and for that, we also have a built-in step called build. So you don't need to worry about running explicit Docker commands. You just set the type of the step as build. And you give your image any name, you point to the Docker file in your repo that you would like to build. Of course, you can define any variables here. You can set them as encrypted if you want. So I gave my image a name. I tagged my image with the commitcha from GitHub. So this is something that I like to do, and I tell you why. So of course you can give your image any tag, but giving it the tag of my commitcha lets me then easily trace back the changes back to the code chain. So I can see the image that is deployed to my cluster, and I see exactly what the changes that I made in my repo reflect in my deployment. Then for running unit tests, I didn't really actually run any unit tests here, just show the ability to do that. So with CodeFresh, as every step runs in a Docker image, you can always create what we call a freestyle step, which means that you can point to any Docker image for this specific step, and then run any commands and these commands will run in the context of this Docker image. So let's say you have a Go application, you can just pull the official image of Go with the version that you need from Docker Hub or from any private Docker registry, and then run your Go tests. Or this is of course true for Node or Java or any tool that or technology that you want to use. Then I'm going to push my image to ECR, and for that I integrated my ECR registry to CodeFresh, and I can just use the push step type, choose the image that I would like to push, and you see that here, instead of specifying a hard-coded value for my image, I can just use a variable with the name of the step that built my image. So this will instruct CodeFresh to push the image that was built in this step to my ECR registry. And as a tag, I'm going to give it the branch plus the commitcha. And finally, for the deployment itself, we have this built-in step for deploying to ECS, and you can also find it here. We also have one, by the way, for blue-green deployment for ECS. So when I'm saying ECS here, this works both for Fargate and for EC2 launch types, as the actual architecture in terms of deployment is the same. You can easily deploy to your ECS clusters, and you see it's a completely declarative manner. You can just provide the name of your cluster, the service. Here I also provided the image that I would like to use. So this is how I point to the new image that I created using variables, and I push to ECR, and this is what I'm going to use for the deployment. I can pass my AWS credentials, and here I then did something cool that I'll explain again. So we will run this Python again, and then we will have like a deep dive for each of these steps. By the way, to share data between steps in the pipeline, as each step runs a container, what we do is we provision a volume for each pipeline, and we then mount this volume to each container in the pipeline. So once I clone my repo, all of my project files will be placed on this volume, and then I can seamlessly access them from any subsequent steps. So this is also true for dependencies, for example. Let's say you want to download some dependencies like node modules, and you want to use them in a subsequent step for running unit tests, for example, then you only need to download them once. They will then be placed on the volume of the pipeline, and we can then access them in any subsequent step that will run a test. So this is for passing data between steps. As far as the caching goes for Docker, so CodeFresh has built-in Docker cache as well as distributed layer caching. So if I look at the actual execution that we just ran together, and I look at the logs for building my Docker image, right, I can see for each of the layers that were built, if they were built and taken from cache or no. So it does show it here in the logs. I think I can see it from the previous execution. Let's see. Yeah, right. So you see here that it used cache for building all of these existing layers. Cool. See, I have a few questions here, and we will get to all of the questions at the end. So don't worry, keep on posting these questions. One more thing that I wanted to show you, let's rerun the pipeline, but this time I'm gonna run it with debug mode. And this is a cool feature that lets you add breakpoints like in any IDE. Then once the pipeline will reach this breakpoint, it will pause, and it will let you run any command to debug your pipeline. So here, let's say I added a breakpoint here before building my Docker image, and then I can also do it before the actual deployment. So let's say you run a pipeline, something fails, something breaks, you're not sure what. You can just, instead of rerunning the pipeline again and again and just printing stuff to the log, you can run it with debug mode, add a breakpoint, and you see that it cloned my repo. I got to the breakpoint before building my Docker image, and it popped this debug shell, and I can then run any commands to debug my pipeline. So what you see here is that the working directory is codefresh/volume. That's the volume of my pipeline. And if I look here, I see that indeed, as it's not the first time I'm running this pipeline, it's reusing a volume that was already created in a previous execution. So I can then go and run the ls command, and I see my Git repo that was cloned in the previous step. And I have access to it, as I mentioned, because we mount the volume of the pipeline to each of the containers in the pipeline. So I can go and see all of my source code. I can print my Docker file. I can see anything that might be wrong here that failed my pipeline. I can run the env command to see all of the environment variables that are used in my pipeline. So everything that came together in the webhook from my Git repo. or anything that I managed inside CodeFresh as variables. And once I'm completed, I can just click on continue, and it will continue building my image and then pushing it and continue with the deployment. Let's remove this part. Another thing that I wanted to show you here is that for managing the actual deployments, we added something called an environments view. So you see, I have my environment here called Fargate Prod, and I see that now it's in progress, right? Because I'm actually performing the deployment as we speak. And I see this live status of my environment. And I see that it's now in progress. Once the deploy step will be completed, this will change to deployed, and I will be able to understand that the status of my environment is now stable. And this is cool because it lets you link your deployment environments back to the pipelines that make changes to your actual environments, right? So I see that there is actually a deployment happening right now. So in the logs of this deploy step, it shows you the running count, the desired count, and the pending count of your tasks, and it will consider your deployment a successful deployment once the running count equals the desired count of tasks. So this is for building and executing my pipeline. So going back to the presentation, we talked about the deployment flow. We saw the demo. So to summarize what we saw in this webinar, and then of course we will get to the questions, is you can use Fargate as it lets you focus on developing your app, focus on your containers while letting AWS manage the infrastructure for you. So you don't have to manage the actual EC2 instances and patch them and worry about them. The second thing is the easy deployment that we saw using this open source built-in step for Fargate or ECS. Just to show you that indeed it's open source, if you go to codefresh.io/steps, you'll see the library of all of our steps here. You can go to deployments and you'll see this ECS deploy step. All of our steps are open source, so you can see the actual source code for these steps. And like with any other step in CodeFresh, it's running as a Docker image, right? So I can see the Docker file running. It's going to execute some Python script, and that will handle the logic of this step. So feel free to go and see exactly how it works. And of course, you can also make changes to it as it's open source, fork it and play around with it. And finally, you can also get speedier builds thanks to the caching mechanism that I mentioned for caching the Docker images as well as the layers. So thank you very much. And I think, Taryn, we can now go
Yes,
to
thank you so much, Guy. We have a lot of questions and a lot of interest in Fargate. You can take a look at the questions as well as if you'd like, or I can moderate them to you. But we'll start with, I'll just let you know what first question is from Alan. What makes Fargate better than Google, Azure, Red Hat, OpenShift, Docker, Kubernetes, and other competitors? Seems like it's just a different type of cluster solution. What about enterprise support? Does Fargate offer similar enterprise support as Red Hat, Docker, or Azure?
So yeah, there's a lot of terms here, and we'll try to make some order in this. So Docker is just the technology for creating your images, right? And containers. And then you have container orchestration tools like Kubernetes, for example, which is a platform, a solution that helps you manage your containers, lets you run them side by side, handles auto scaling and all that stuff. So you can compare Fargate, ECS and Fargate for that matter, to Kubernetes, but they both use Docker or can use Docker as the container runtime Fargate compares to Kubernetes. This wasn't the actual topic of the webinar, but I know that a lot of users are considering whether to use this or that. With Kubernetes, I guess you do have more control, but you do have more to study and learn about how to optimize your cluster, etc. As with Fargate, it's a bit easier, right? You just have to specify the images that you want to use, and AWS will do the rest. So in terms of infrastructure and learning curve, Fargate would be, I guess, easier to get started with. In terms of pricing, I don't know the exact details, and it also very depends. But Fargate can be a bit more expensive, and again, less manageable in that sense.
Thanks, Guy. And then the next question, and this refers back to your slide 7, just to clarify one last time. If old task means old version and new task means updated or new version of the same task. He just wanted to confirm if that was correct.
Yes, this is correct. And I'll just need to log back into my AWS account, and we can see exactly how this looks like in my cluster. So going back to my account. Okay, so I'll go to my ECS cluster. And if I look now at my cluster under my service, I see the task, and you see it's all the same tasks, just a different number here for the revision, right? So I can click on each of these tasks and I see the amount of resources that are allocated to them, and I can see the image that each of them are pointing to. So this is pointing to master with this tag, which is the commit SHA. And if I go back, I can see the other revisions pointing to other tags. So correct, yeah, it's different revisions of the same task definition.
Okay, thank you. And then let's see, our next question is, can Fargate be used on Amazon Elastic Beanstalk engine as well?
No, not at the moment. So it's currently supported as a serverless compute engine for ECS and for EKS. Not for Elastic Beanstalk, as far as I know.
Okay, and let's see, what is the best practice to stop the old tasks? Do we need to wait until the new one is running and then stop the old one?
Yes, so this is something that is handled by the step that we created. And just to emphasize again, this step, right, is simply a Docker image. So you can even use it without using CodeFresh, right? It's not even tied directly to CodeFresh. And you can go and see the actual ECS update service and see how we implemented it. But you can see the complete deployment flow here. So, and also in the link that I shared inside our documentation. So what we implemented is, this is what we decided that would be the best thing, is the step will first search for the service according to the name that you provided based on the region, the cluster name, service name. It will then create a new revision for the task definition, right? And you can specify an image and tag to replace the task definition. And then it will run the update service, and it will start this flow, and it will always check the running count compares to the desired count for the primary deployment. So you have the active deployment, the primary deployment. So as to for your question, yeah, it will create a new revision. It will not remove the old task revision until we make sure that we have this condition met. You can also add some health checks to the actual step and make sure that the health checks run and you get the desired response before you kill the previous revision.
All right, thank you. And then Alan says he's still trying to understand how this improves the pipeline and all associated resources. So can you explain any more detail about the compute engine itself? Like Fargate as all the services required encapsulated, or Fargate is just a stripped down OS that integrates with the AWS servers?
Sorry, can you repeat the question, the last part of it anyways?
Sure. So he says, can you explain any more detail about the compute engine itself? So Fargate as all the services required encapsulated, or Fargate is just a stripped down operating system that integrates with the AWS servers?
Good question. So yeah, it is encapsulated, and that was like one of the reasons that they created Fargate, is that the whole point is don't worry about the other things, don't worry about the infrastructure and the actual instances that will run behind the scenes. Let us, meaning AWS, worry about that, where you only have to worry about the container that you want to run and how many resources you would want to allocate to this container. And this is also true for the billing part. So, right, you only pay for the resources. So yeah, there are some things once you go and create a new cluster, right? We can go and, for example, getting started and create some cluster. You see, you can create it as a Fargate cluster, and then you'll see that as part of this like quick start guide, you can decide, yeah, I want to use it with a load balancer, application load balancer with this port, and then give the cluster any name, and then Amazon will go and create all these things for you. So it will create the cluster, it will create the first task definition, it will create a log group and a CloudFormation stack, a VPC, 2 subnets, all these things for you. So all of these things are created, but you just don't really have to worry about them. So that's for this question.
All right, and we have a lot more questions, so we'll just keep chugging along until the top of the hour. So we have another 10, 12 minutes or so. Next question is, what is the best practice to provision initial service? We use Terraform for this, but wouldn't it revert the deploy if executed?
So for my demo, what I did is I created this cluster. Then once creating the cluster, you can, at the initial creation of the cluster, you can point your task to any image. So before I create the cluster, I pushed my Docker image to ECR. Then I was able to create my cluster and point my task definition to this image. And once I did that, I went to CodeFresh, and I could then create the automatic flow. So I first had some, I did like a manual deployment, sort of say, before building and running my actual CI/CD pipeline, as this is also one of the requirements of the task. So if you look at the prerequisites of this built-in deploy step, right? You first, of course, you have to have an ECS cluster to deploy to, and it should have at least one running instance. This is more for EC2 launch type thing. And you need to have a service, you need to have a task definition. Then you have to make sure that your ECR registry is connected to CodeFresh, and that you have the AWS credentials with the following privileges. So yeah, first make sure that we have all these. And you can do like any infrastructure as code using Terraform, right? So instead of going and doing these manual clicks in the UI, of course, you can also have a Terraform script and template to create this cluster, point to the image that you would like to use, etc. But you then don't need to, unless you want to create clusters on the fly, you don't really need to run it again. So you just need to have it once to create a cluster. Then you can have your pipeline just deploying to this cluster, changing the task definition revision, with the new changes of your application.
All right, and our next question is from Ricky. Is there a minimum number of containers that ECS requires you to run?
Only one. So yeah, you can have one container. This is what I'm having actually in this demo, right? So I only have one container running in my task. And of course, you can scale up to as many as you want. But yeah, for the minimum, it's only one.
Thanks. And Saravana asks, can I set up CodeFresh CI/CD on-prem as like Jenkins?
You can. So CodeFresh, the standard offering of CodeFresh is it is a SaaS platform, right? So you can go and just sign up for an account. We also have a full on-premise offering where you can just go and install the whole CodeFresh application on your own cluster on-premise. And it can also be behind the firewall, completely disconnected from the internet. We also have a third offering, which is very popular among a lot of our users, which is our hybrid mode. Means that you can sign up to the SaaS platform, but what you can do is then install our agent, the CodeFresh runner, on your cluster behind the firewall. And this is very cool because you get like the best of both worlds where you're using a SaaS platform, so you don't have to manage and maintain the actual platform yourself, right? So let's say CodeFresh releases a new feature, fixes some bug, like pushes some improvements, then you get them seamlessly, right? But the pipelines can run on your own infrastructure. And I know, and I saw a question also about using the AWS credentials, and this is a good point. So if you noticed, I am importing my AWS access key and secret key, and I'm going to use them in my pipeline, right? And some users, I guess, are concerned about storing the AWS credentials in the cloud, right? Because we're using a SaaS platform. What you can do is, and I actually have a demo for this here, is if you really go and install this agent that I just mentioned, you can then go to CodeFresh and you can choose for each of your pipelines on which runtime environment it will run. So instead of running on a cloud-hosted environment, here I specified my runner. So my runner, I installed it on some EKS cluster that I have. It's my own cluster running inside a VPC. And then with EKS, what you can do, and you see that what I did in this pipeline, I just used some the image of AWS CLI, and I didn't provide any variables for this pipeline. So you see, I don't have my AWS credentials, but still I was able to run commands and get access to my AWS resources, like viewing my images in some specific region, because my EKS cluster assumes a role, an IAM role from AWS. So this is something with like another layer of security that you can do. You can, if you don't want to have CodeFresh completely SaaS running your pipelines in the cloud and storing your AWS credentials in the cloud, you can install this agent on your own EKS cluster, and then you don't have to manage your credentials in the cloud. Your cluster would just have access to your AWS resources based on the role that it has.
All right, and we're just getting down to the last 5 minutes, so I just want to launch a poll. We really appreciate your feedback, and we'll just continue with the questions while you answer that. Let's see, from Romans, can you also recommend a good practice to revert the deploy without going through all build steps?
Yeah, so to be honest, we don't have this implemented in this step. However, if you do want to use Fargate, you want to use ECS or Fargate, and you want to have like a built-in rollback, you can use our pretty new ECS blue-green deploy step. So this, as opposed to the step that I showed you, will be able to, and it's using Codeploy, which is also a service provided by AWS, it will have two deployments in parallel. So one will be my old one with the new one, and it has some built-in health check running as part of this step. And if the health check fails, it will roll back to the previous version, just like any blue-green deploy. So you can look into this step if you want some built-in rollback functionality.
Thanks. And how, let's see, how to roll back a deployment made in Fargate?
So this is exactly how you do that. So you can use Codeploy for that. I can show you a bit of the source code of this step, but so that's maybe we changed the repo for it. But there is something called Codeploy in Amazon. We don't have much time left, but this is a service of AWS that lets you have more advanced deployments, and you can then use our blue-green ECS step to have a blue-green deployment for Fargate. And as a blue-green deploy step, it has built-in rollback functionality. So it will spin up two instances of your application, one with the old version, one with the new one. It has some built-in health check on the new version, and if the health check passed successfully, it will remove the old version and make the new version as the production version. But if the health check fails, it will then roll back to the previous version before the change and remove the new version, in a sense. So this is how you can do rollback deployment in Fargate.
And how do you control versioning in the pipeline?
So for versioning, as I mentioned here, I use the built-in YAML option. But what you can do is you can take this YAML file and pull it from your Git repo. And then you can manage this pipeline under version control. And like any other file in your Git repo, it will be managed under version control. So if you make any changes to it, of course, these changes will be recorded in Git, and you'll be able to revert changes. You'll be able to see the differences between changes, between versions, etc. So this is what I recommend for versioning.
All right, thank you. And do we need to have one ALB per service, or can we have one ALB for all of the services of a cluster?
So yeah, for the demo that I did, I had one service and one ALB for my service. I'm actually not sure about if you can have one ALB for all of the services. I think you can, but I didn't play around with it enough to make sure. So good question, but I'll have to look into this.
And can you talk a little bit more about environments for Jonathan?
Sure. So the environments feature of CodeFresh is a feature that provides like an abstract layer on top of your environment. So an environment currently it can be either a Kubernetes cluster or a Helm release. And this gives you like a link between your development environments and your pipelines. So in the world of microservices, as you make changes sometimes multiple times a day and multiple deployments a day, it's difficult to keep track on what were the latest changes that were made to my environment. And then suddenly, if you see that your environment is down, for example, I see that this environment is now down, it's difficult to understand what were the changes that caused it to go down. So the old traditional approach would be to just go through the logs and try to find something there. With this environment feature, you can go to the last pipeline that made a change to your environment, and you can see the actual step that failed, and then see exactly what was the reason and what's the reason for your environment to be down. So I know that we're running out of time, but just to show you how you can make your pipeline influence the environment. This is the part here that I said that I'm going to talk about. So you can add this env option, and then it will create an environment for you. So you can provide a name, a URL. I set this as type Kubernetes, but it doesn't really matter. It can be any kind of environment, even though Fargate, in my case, is not Kubernetes. It still shows you the actual environment. And you can see the commit message here, and you can go and link back and see all of the latest pipelines that made changes to my Fargate cluster.
And just in reference to the last question about the number of ALBs per service, it looks like Roman's answered it in the chat. It's 1 ELB per service, but you can also use App Mesh, which has no code overheads and uses DNS. So thanks for your comment there, Romans. So we still have a couple questions, but we are right at the end of our time. So I'll tell you what I'll do. I'm going to export all of these questions and make sure that we get these answered for you. So I'll make sure that we review all of these and that we reach out to each of you if we didn't have time for your question. But thank you all so much for attending, and we hope you have a great day and that you join us again on CodeFresh. And do you have any closing comments, Guy, that you wanted to mention before we finished?
No, so I appreciate everybody for joining and all of the questions. I had a great time, and yeah, just finished with my with my thank you slide here, and remind you that you can sign up for a free account, again, get unlimited builds, and of course you have my email address here, so feel free to ping me for any questions, any help about CI/CD, Fargate, Kubernetes, whatever.
And I will be sending out the recording to you tomorrow. And like I said, if we didn't get to your question, we'll make sure and email you. So thank you everyone so much. And especially thank you to Guy for this great presentation. Have a great rest of your day.